A man died in 1810 worth more than most nations, having weighed the earth itself. Yet almost nobody outside scientific circles knew his name. He spoke to virtually no one, feared women so intensely he built secret staircases to avoid them, wore the same style of clothing for 50 years, and made discoveries that wouldn't be properly credited until a century after his death. This is Henry Cavendish, and his story reveals something unsettling. Sometimes the mind capable of understanding the universe is utterly incapable of understanding people. October 10th, 1731. Nice, France. Not the most obvious birthplace for one of England's greatest scientists, but the Cavendish family wasn't in France by choice. Henry's mother, Anne Grey, had poor health. The mild Mediterranean climate was supposed to help. It didn't. She would be dead within 2 years. 3 months after giving birth to Henry's younger brother Frederick. Henry wasn't even 2 years old when he lost his mother. He would spend the rest of his childhood, and indeed his entire life, in the care of his father, Lord Charles Cavendish. That early loss might explain everything that came after. Or it might explain nothing. We'll never really know, because Henry Cavendish left almost no record of his inner life. What we do know is that he was born into ridiculous privilege. His father was the 3rd son of the Duke of Devonshire. His mother was the 4th daughter of the Duke of Kent. 8 centuries of aristocratic lineage stretched behind him, connecting the Cavendishes to virtually every important family in Britain. This wasn't merely wealth, this was power, status, the kind of social position that opened every door in Georgian England. Most people born into such circumstances would have pursued politics, military glory, or at minimum, a life of conspicuous leisure. Henry Cavendish did none of these things. He would spend his inheritance on thermometers and lead spheres, an experimental apparatus that no one else understood the purpose of. His father brought him back to England after his mother's death. Lord Charles was himself an unusual aristocrat. Yes, he'd served in politics early in his career, but his real passion was science. He became a Fellow of the Royal Society, conducted his own experiments, built scientific instruments. The man was genuinely curious about how the natural world worked. In young Henry, he recognised something, a mind that operated differently from other children's minds. More precisely, perhaps, more systematically. Lord Charles didn't try to force his son toward a conventional, aristocratic career. Instead, he did something remarkable. He encouraged the strangeness. At 11, Henry was sent to Dr. Newcome's Academy at Hackney. This was a private school catering to the sons of upper-class families, the kind of place where you learned Latin and Greek, mathematics, and natural philosophy. The curriculum was classical, rigorous, designed to produce gentlemen who could quote Cicero and calculate compound interest. Young Henry absorbed it all, but left no particular impression. He wasn't the standout student, the prodigy who amazed his teachers. He was competent, thorough, unremarkable, in the way that very remarkable people sometimes are when they're still figuring out what makes them different. Then Cambridge. In 1748, at 18, Henry entered St. Peter's College, now known as Peterhouse. He enrolled as a fellow commoner, a status reserved for wealthy students that came with various privileges: better rooms, the right to dine at the fellows' table, exemption from certain regulations. Fellow commoners paid higher fees and in return received preferential treatment. Many of them never bothered completing their degrees. The degree itself mattered less than the social connections formed, the gentleman's education acquired. Henry Cavendish stayed at Cambridge for 3 years and left in 1751 without taking his degree. Why? Speculation has swirled around this question for over 2 centuries. Some suggested he objected to the religious tests required for graduation, which demanded affirmation of Church of England doctrine. But we know almost nothing about Cavendish's religious views, and what little evidence exists suggests he simply wasn't interested in religion one way or another. His biographer would later write flatly that as to Cavendish's religion, he was nothing at all. That's a striking statement about a man living in 18th century England, where religious belief was assumed, expected, woven into the fabric of social life. More likely, he left Cambridge for the same reason many fellow commoners did. He'd gotten what he needed from the place. He'd received an excellent education in mathematics and natural philosophy. He'd learned Latin thoroughly enough to read classical and contemporary scientific works. He'd absorbed the experimental methods then being developed. The formal degree would have required jumping through hoops. He saw no point in jumping through. So he didn't. He returned to London and moved in with his father. Lord Charles set him up with his own laboratory, complete with instruments, workspace, everything a young experimentalist could want. And here's where Henry Cavendish's life takes its peculiar shape. He was 20 years old, heir to enormous wealth, connected to the highest levels of British society. He could have done anything. Instead, he chose to do science. Not as a hobby, not as the gentlemanly pursuit of an aristocrat with time to kill. Science became his entire existence. His father understood. Lord Charles had by this point largely withdrawn from politics and was devoting himself increasingly to the Royal Society of London. In 1758, he began taking Henry to Royal Society meetings. He introduced his son to the leading natural philosophers of the age. He brought him to dinners of the Royal Society Club, the exclusive group that met before the Society's weekly meetings. These weren't just scientific gatherings. They were social events where Britain's intellectual elite discussed everything from experimental results to politics to gossip. For most people, this would have been networking, career building, the cultivation of useful relationships. For Henry Cavendish, it was something else entirely. It was a structured environment where his social awkwardness could be overlooked because his scientific expertise was so evident. People at these dinners learned quickly how to interact with him. You didn't approach Henry Cavendish directly and strike up a conversation. That wouldn't work. Instead, you positioned yourself near him and spoke as if into empty space, making scientifically interesting observations. If what you said was worthwhile, you might receive a mumbled reply. If it wasn't, you received nothing at all. This wasn't rudeness. This was simply how his mind worked. He couldn't do small talk. He couldn't do social pleasantries. But he could discuss experimental apparatus or the properties of gases or astronomical observations with a precision that left other scientists impressed and slightly unsettled. In 1760, at age 29, Henry Cavendish was elected to both the Royal Society and the Royal Society Club. He attended regularly, faithfully, for the rest of his life. These meetings would become his only real social outlet. He had no friends in the conventional sense, no social life beyond these scientific gatherings. He formed no romantic attachments. He seems to have had no interest in such things. Or perhaps he simply couldn't navigate the social complexity they required. His father kept him on an extremely tight allowance during these years. This seems almost cruel given the family's wealth, but Lord Charles apparently wanted his son to understand the value of money. Henry became careful with spending, showing up to Royal Society dinners with exactly 5 shillings, the minimum required for admission, and not a penny more. He developed habits of frugality that would persist even after he became one of the wealthiest men in England. Years later, when he finally inherited his fortune, he would remain parsimonious in personal expenditures while being oddly systematic in his charitable giving, always checking the list of previous donors and giving precisely the amount of the largest donation. Not more, not less. Exactly matching the highest contribution, as if this were a mathematical problem with a correct answer. But that's getting ahead of the story. In 1760, Henry Cavendish was still a young man, still living with his father, still finding his way in science. He had the resources, the education, the connections. What he didn't have yet was the work that would define him. That was coming. His first major paper, on what he called factitious airs, wouldn't appear until 1766. But the foundation was being laid. The laboratory was equipped. The methods were being refined. The mind that would eventually weigh the earth was learning how to ask questions that no one else knew how to ask. His daily routine was already taking the shape it would maintain for decades. He worked in his laboratory, he attended Royal Society meetings, he avoided social interaction whenever possible. He dressed in the same style of suit year after year, calling his tailor to make exact replacements when the old ones wore out. The suits were always slightly out of fashion, as if he'd locked onto a particular style in his 20s and saw no reason to ever change it. 50 years later, he'd still be wearing essentially the same outfit, now comically outdated, but he wouldn't care. Fashion was irrelevant, only the work mattered, and the work was becoming something extraordinary. While other natural philosophers were still arguing about phlogiston and trying to understand combustion, Cavendish was developing experimental techniques of almost unbelievable precision. He was learning to measure things that other scientists thought couldn't be measured. He was designing apparatus that could detect differences too small for most instruments to register. He was building a scientific practice based on systematic observation, careful measurement, and relentless attention to potential sources of error. His shyness, his social awkwardness, the personality traits that made him so difficult to be around, these same qualities made him an exceptional experimentalist. He could spend hours watching a torsion balance oscillate, recording each tiny movement with perfect patience. He could repeat the same experiment dozens of times, looking for patterns, identifying problems, refining his methods. Where other scientists might lose patience or decide an experiment was good enough, Cavendish kept working, always checking, always improving, never quite satisfied. This obsessive attention to detail, this inability to leave well enough alone, it would eventually produce results that wouldn't be matched for generations. But in 1760, he was just getting started. The major discoveries lay ahead. The weighing of the earth, the composition of water, the detection of argon a century before anyone else confirmed it, all of that was still to come. What existed now was potential. A strange, brilliant, deeply awkward young man with unlimited resources and a mind that saw the world differently from everyone around him. His father watched all this with what must have been a mixture of pride and concern. Lord Charles had given his son the tools to pursue science. He'd introduced him to the Royal Society. He'd created an environment where Henry's unusual talents could develop. But he must have wondered what would happen when he was gone. Who would look after this peculiar young man who couldn't speak to women, who communicated with servants through written notes, who seemed incapable of forming normal human relationships? The answer, as it turned out, was that Henry Cavendish would look after himself. He would live alone, work alone, die alone, leaving behind experimental notebooks that would astound later generations, and a personal life so empty of human connection that biographers would struggle to find anything to write about beyond his science. But that emptiness, that absence of normal human entanglement, it was also a kind of freedom. Cavendish wasn't distracted by social obligations, by family drama, by the pursuit of status or romance or any of the things that consume most people's energy. He could focus entirely on understanding how the natural world worked, and he would use that focus to make discoveries that would reshape human knowledge. The stage was set, the laboratory was ready, the mind was prepared. What happened next would establish Henry Cavendish as one of the most important scientists of his age, even if almost nobody outside scientific circles would ever know his name. The first real test came in 1766. Cavendish was 35 years old, had been a member of the Royal Society for 6 years, and had published exactly nothing. He attended meetings regularly, he served on committees, he examined instruments and offered technical advice, but he hadn't contributed a single paper to the Society's transactions. Not one published word of original research. This wasn't because he hadn't been working. His laboratory notebooks were filling with observations, measurements, experimental procedures. He was conducting systematic investigations into the properties of different airs, the term used for what we'd now call gases, but publication required something Cavendish found nearly impossible, putting himself forward, claiming priority, asserting that his work deserved public attention. Then something shifted. Perhaps his father encouraged him. Perhaps colleagues at the Royal Society pressed him to share what he'd discovered. Perhaps Cavendish simply reached a point where the work felt complete enough to present. Whatever the reason, in 1766 he submitted his first paper, On Factitious Airs. The paper described experiments with what Cavendish called inflammable air. Others had produced this gas before. Robert Boyle had generated it a century earlier by mixing iron filings with acid. But Boyle hadn't understood what he'd made, had confused it with ordinary air. Cavendish recognized that inflammable air was something distinct, something fundamentally different from the air we breathe. He measured its properties with characteristic precision, its density, its behavior when mixed with other substances, the way it burned. He collected it in glass vessels inverted over water, measured volumes with exacting care, recorded everything in his meticulous handwriting. The experiments themselves weren't particularly dramatic, mixing acids with metals, capturing gases, measuring weights and volumes. But the attention to detail, the systematic approach, the determination to quantify everything precisely. This established a new standard for chemical investigation. What Cavendish had discovered, though he didn't know it yet, was hydrogen, the lightest element, one of the fundamental building blocks of matter. Antoine Lavoisier would later give it that name, hydrogen, meaning water former. But in 1766, Cavendish just called it inflammable air and focused on describing exactly what it did. The paper was well received. Scientists recognized immediately that this was serious work, careful and thorough in ways that set it apart from the more speculative chemistry of the era. Cavendish had proven he could contribute meaningfully to natural philosophy. He'd established himself as more than just a wealthy amateur attending meetings for social purposes. But here's what's interesting. Success didn't change his behavior. He didn't suddenly become prolific, rushing to publish everything he'd discovered. Instead, he returned to his laboratory and continued working at his own pace, publishing only when he felt absolutely ready, when the work met his impossibly high standards. The next paper wouldn't appear for years. This pattern would define Cavendish's entire career. Long periods of intense private experimentation, punctuated by occasional publications when the work finally satisfied him. Most scientists of his era published frequently, often prematurely, racing to claim credit for discoveries. Cavendish did the opposite. He let experiments marinate for years, repeating them, checking for errors, considering alternative explanations. Publication was almost an afterthought, something he did reluctantly when the scientific community needed to know what he'd found. What was he doing in those years between papers, working on problems that fascinated him, regardless of whether anyone else cared about them? Designing new apparatus, improving old instruments, reading everything published by other natural philosophers, and checking their claims through his own experiments, building a body of knowledge that existed primarily in his notebooks, seen by almost no one. His laboratory at his father's house was expanding. More equipment, more space devoted to experiments. The drawing room had become essentially a chemistry laboratory. The upper floors contained astronomical instruments. The lawn outside was used for observations and measurements. Every part of the house served scientific purposes with only minimal space reserved for actual living. Lord Charles watched all this with what must have been mixed feelings. His son was making genuine contributions to science, earning respect from the Royal Society's most prominent members. But Henry's social situation wasn't improving. If anything, he was becoming more isolated, more eccentric, more focused on work to the exclusion of everything else. The Royal Society dinners continued to be Cavendish's primary social outlet. He attended nearly everyone, sitting at the same spot at the table, eating the same food, following the same routine. Fellow members learned to approach him carefully, speaking as if addressing the air near him rather than directly to him, waiting to see if he'd respond. Sometimes he would, if the topic was scientific and the person didn't press too hard. More often, he'd simply remain silent, listening without engaging. Other scientists found this frustrating. Here was clearly a brilliant mind, someone who understood natural philosophy as deeply as anyone in England, possibly Europe, but trying to have a conversation with him was nearly impossible. He wouldn't debate, he wouldn't speculate, he'd only discuss experiments he'd actually performed and results he could verify. Everything else was pointless talk. This created a strange dynamic. Cavendish was respected, even revered, but also kept at a distance. Nobody quite knew how to interact with him. He attended meetings but barely participated. He served on committees but rarely spoke. He was simultaneously present and absent, part of the scientific community but never really belonging to it, and the eccentricities were multiplying. His insistence on wearing the same style of clothing, decades out of fashion. His habit of communicating with female servants only through written notes left in designated places. His apparent inability to spend money on anything except books and scientific instruments, despite being extraordinarily wealthy. His walks taken only at night to avoid encountering neighbours. Some people found this amusing, others found it sad. A few found it infuriating. This wealthy aristocrat who could have done anything with his advantages, but chose instead to live like a hermit, obsessed with experiments that most people couldn't understand and didn't care about. But here's what those critics missed. Cavendish wasn't just doing random experiments. He was pursuing a coherent program of investigation, trying to understand the fundamental nature of matter. What were these different airs? How did they relate to each other? What happened when you combined them? These questions might seem abstract, but they were actually about the most basic aspects of physical reality. And Cavendish had advantages that made him uniquely suited to answer them. He had resources to build any apparatus he needed. He had time to conduct experiments as carefully as required. He had no obligations pulling him away from the work, no family to support, no career to manage, no social life to maintain. Everything that made him a difficult human being made him an exceptional scientist. The breakthrough that would establish his reputation was still years away. But the foundation was being laid, experiment by experiment, measurement by measurement, observation by observation. Cavendish was learning things about the physical world that nobody else knew. He was developing techniques that nobody else had mastered. He was building toward discoveries that would fundamentally change human understanding of matter and energy. 1766 had proven he could contribute. Now he just needed to keep working, keep measuring, keep questioning everything. The inflammable air was interesting, but it was just the beginning. There were other airs to investigate, other properties to measure, other secrets waiting to be discovered by someone patient enough and precise enough to uncover them. His father's health was declining. Lord Charles was in his 70s now, still active in the Royal Society, but slowing down. The relationship between father and son remained centred on science, conversations about experiments and observations, shared interest in the work being done by natural philosophers across Europe. It was the only kind of closeness either of them seemed capable of. What would happen when Lord Charles died? How would Henry manage alone? These questions must have occurred to people who knew them both, but nobody asked directly. You didn't press Cavendish about personal matters. You barely pressed him about scientific ones. You waited for him to speak, and mostly he didn't. The work continued. That was what mattered to Cavendish. Not reputation, not social connection, not even publication really. Just the work itself. the daily practice of investigation, the slow accumulation of knowledge through careful observation. Everything else was noise, distraction, irrelevance. And the next major discovery was closer than anyone realized, waiting in experiments with water and fire, in measurements so precise they'd shock the scientific world, in questions about the composition of the most common substance on Earth. The experiments with water began almost by accident. In 1781, Joseph Priestley mentioned something curious to Cavendish. When you sparked inflammable air together with ordinary air using an electrical machine, water appeared, just water, condensing on the sides of the vessel. Priestley found it interesting, but didn't pursue it. He was busy with other investigations, other gases, other questions. Cavendish heard this and immediately saw what it meant. Water wasn't an element, it couldn't be. If you could create it by combining two different airs, then water had to be a compound, made of something else, built from components. This was heresy. For thousands of years, going back to the ancient Greeks, water had been considered one of the four fundamental elements: earth, air, fire, water, the building blocks of everything. You couldn't make water from other substances any more than you could make earth from water or fire from air. But here was Priestley saying he'd done exactly that. Cavendish set up his own experiments immediately. But he didn't just repeat what Priestley had done. He modified the approach, made it more precise, controlled the variables. Instead of ordinary air, he used dephlogisticated air, what we now call oxygen. This made the experiment cleaner, more specific. Inflammable air plus dephlogisticated air sparked together electrically. The result was always the same: water. He measured everything: the volume of inflammable air consumed, the volume of dephlogisticated air consumed, the weight of water produced, the ratios between them. Other chemists might have stopped after a few successful trials. Cavendish ran the experiment again and again, adjusting conditions, checking for errors, verifying results. The measurements kept coming back consistent. 2 volumes of inflammable air combined with 1 volume of dephlogisticated air to produce water. Almost exactly. The implications were staggering. Water, the substance that covered most of the Earth's surface, the liquid essential for all life, wasn't simple at all. It was compound, made of 2 gases that were themselves completely different from water in every property. 1 gas burned, 1 gas supported burning. Together, they made something that extinguished fire. Cavendish published his results in 1784 in a paper for the Royal Society. The measurements were impeccable. The conclusions were unavoidable. But then something frustrating happened. Antoine Lavoisier in France got wind of the discovery. He ran similar experiments. And then he published his own paper, claiming credit for discovering the composition of water. Worse, Lavoisier gave the inflammable air a new name: hydrogen, from Greek words meaning water former. The name stuck. Within a few years, everyone was calling it hydrogen instead of inflammable air. Cavendish never complained publicly about the credit issue. That wasn't his style. He'd published his findings. They were in the philosophical transactions. Anyone who wanted to check could see he'd done the work first, measured it more precisely than Lavoisier. But this was a pattern that would repeat throughout his career. Cavendish would discover something, measure it carefully, publish it, then someone else would make a bigger noise about the same discovery, and history would remember their name instead. It bothered people who knew Cavendish. His friends at the Royal Society saw the injustice, but Cavendish himself seemed genuinely indifferent to fame. What mattered was the knowledge, the measurement, the truth about how nature worked. In 1783, Lord Charles Cavendish died at the age of 78. The relationship between father and son had been unusual but genuine, built entirely around science, maintained through shared experiments and discussions about natural philosophy. Now it was gone. Henry inherited everything. The already substantial Cavendish fortune doubled. He became quite suddenly one of the wealthiest men in England. The money made no difference to his lifestyle whatsoever. He still wore the same outdated clothes, still lived in houses organised around laboratories and libraries rather than comfort, still walked alone at night to avoid encountering neighbours. But the inheritance did allow him to expand his scientific facilities. He bought a house at Clapham Common, south of London, and converted it entirely into a laboratory and observatory. The main house in town became primarily a library, eventually holding one of the most complete scientific collections in England. He made it available to other researchers. If you were a serious natural philosopher and needed to consult a rare text, you could request access to Cavendish's library. He'd grant it, as long as you followed the rules. Check the book out properly. Return it on time. Don't damage it. Several researchers who used the library later wrote about the experience. You'd arrive at the house and be shown to the library by a servant. Cavendish himself would never appear. You'd find the book you needed, sign it out, take it away. When you returned it, again, no Cavendish. The books were for use, not for social interaction. His experiments continued. Through the 1780s and into the 1790s, he worked on multiple fronts simultaneously. There was the composition of air. Everyone knew air was a mixture, but what exactly was in it? Cavendish developed techniques to remove the different components, one by one. First the dephlogisticated air, then the phlogisticated air, then whatever else might be present. He found something odd. After removing everything he could identify, there was always a tiny residue left, about 1 part in 120 of the original volume. A bubble of something that wouldn't react with anything, wouldn't burn, wouldn't support burning, wouldn't combine with other substances. He noted this carefully in his experimental records. He couldn't explain it. The equipment was working properly. The measurements were accurate. But this residue persisted across multiple trials. So he wrote it down and moved on. There was other work to do. What he'd found was argon. But it wouldn't be officially discovered and named until the 1890s, more than 100 years later, by William Ramsay and Lord Rayleigh. When they published their discovery, someone checked Cavendish's old papers and found the measurements. He'd detected it first but hadn't realised what it was. This encapsulates something crucial about Cavendish's approach to science. He didn't force explanations. If the measurement was solid but he couldn't account for it, he recorded it accurately and left it for others to figure out. Better an unexplained observation than a false theory. His work on electricity consumed enormous amounts of time. He built increasingly sophisticated apparatus for generating and measuring electrical charge. He investigated the conductivity of different materials, how electricity travelled through solutions, what happened when you discharged electricity through various gases. Some of this work he published. Much of it he didn't. Not because it wasn't valuable. The electrical experiments were brilliant, ahead of their time in both conception and execution. But Cavendish had a strange relationship with publication. He'd write up results in detailed notes. He'd present findings at Royal Society meetings. But actually preparing papers for the philosophical transactions required effort beyond the experiments themselves. You had to explain your reasoning, describe your apparatus, defend your conclusions against possible objections. Cavendish did this when the results seemed important enough. The composition of water was worth the effort. But many other findings just sat in his notebooks, unpublished. This would cause problems later. Other scientists would make the same discoveries decades after Cavendish, get credit for them, build reputations on findings that Cavendish had quietly achieved years earlier, but never bothered to announce properly. His work on electrical capacity, for instance, he measured it precisely, developed the theory, determined the fundamental relationships, all in the 1770s. None of it was published until James Clerk Maxwell went through Cavendish's papers in 1879, nearly 70 years after Cavendish's death. By that time, Other scientists had independently discovered the same principles and received the recognition. Did Cavendish care? The evidence suggests not particularly. He attended Royal Society meetings regularly. The weekly dinners beforehand were his only consistent social engagement. Other members learned how to interact with him. You didn't approach directly. You didn't make eye contact. You wandered nearby and spoke toward the general air, as if thinking aloud. If your observation was scientifically interesting, Cavendish might respond. Usually he didn't, but he was there, week after week, year after year, present but apart, listening but rarely speaking. The 1790s brought new challenges. War with France disrupted scientific communication across Europe. Political tensions made collaboration difficult. The Royal Society itself became embroiled in disputes about what science should be doing during wartime. Cavendish ignored all of it. Politics didn't interest him. The war didn't interest him. What interested him was a new piece of equipment that had arrived from the estate of John Michell. Michell was a geologist who died in 1793. He'd been building an apparatus for an extraordinary experiment, something that had never been attempted before. He wanted to measure the gravitational attraction between two objects directly, not the attraction between an object and the Earth. That was easy. You just weighed things, but the attraction between two objects sitting next to each other, their mutual gravitational pull, the force would be incredibly weak, undetectably small, with ordinary equipment. But Michell had designed a torsion balance sensitive enough to measure it. The apparatus was incomplete when he died. His executors knew Cavendish was the only person with the skill and resources to finish the work, so they sent it to him in crates. Cavendish unpacked it carefully, studied the design, saw what Michell had been attempting, and recognized immediately that this wasn't just about measuring gravity between objects. This was about weighing the Earth itself. If you could measure the gravitational force between two lead spheres of known mass, and you could also measure the gravitational force between one of those spheres and the Earth, you could calculate the Earth's density, its mass. You could determine how much the planet weighed. Nobody had ever done this. The mass of the Earth was unknown. You could estimate it based on astronomical observations, but those estimates varied wildly. Some calculations suggested the Earth was mostly hollow. Others suggested it was incredibly dense. Direct measurement would settle the question. Cavendish set up Michell's apparatus in a shed at Clapham Common. Then he spent the next several years perfecting it. The design was ingenious but needed refinement. The torsion balance had to be protected from air currents, temperature changes, vibrations. The slightest disturbance would throw off the measurements. He built an enclosure around the apparatus. He observed it through telescopes, watching through windows, so his presence wouldn't affect the readings. He developed techniques for moving the weights remotely, using pulleys so he wouldn't have to enter the room. The actual measurements took months. Each trial involved moving the large lead spheres into position, then watching the torsion balance for hours as it slowly twisted in response to their gravitational pull. The motion was tiny, barely visible even with the telescopes, but it was measurable. Cavendish ran trial after trial. He checked for every possible source of error: magnetic effects, electrostatic attraction, air pressure changes, temperature gradients, vibrations from passing traffic. He tested different configurations. He varied the distances. He rotated the apparatus to check if orientation mattered. Every factor that might influence the result was systematically investigated and either corrected for or eliminated. The calculations were complex. The measurement gave you the ratio between the gravitational force of the lead spheres and the gravitational force of the Earth. From that ratio, if you knew the density of the lead spheres, you could calculate the Earth's density. The result surprised everyone. The Earth was far denser than most people had expected, roughly 5.5 times denser than water. This meant the interior had to be much denser than the surface rocks. The planet had to have a heavy core, probably metallic. Cavendish published the results in 1798. The paper was 57 pages long, meticulously detailed, showing every calculation and every potential source of error. The precision was extraordinary. His value for Earth's density was 5.448 times that of water. The modern accepted value is 5.514. He was off by barely 1%, using equipment that consisted basically of lead balls, wire, and careful observation. The experiment became immediately famous, not because people cared particularly about the Earth's density, though that was interesting, but because Cavendish had demonstrated that gravity, this fundamental force that held the solar system together, could be measured directly in a laboratory. You didn't need to observe planets to study gravity. You could do it with lead spheres in a shed. This opened possibilities that hadn't existed before. Fundamental forces became experimental subjects rather than just theoretical abstractions. Cavendish himself referred to the work as weighing the world. The phrase captured something profound. He'd taken the entire planet and put it on a scale, determined its mass through human measurement rather than divine revelation or philosophical speculation. He was 67 years old when the results were published. Most natural philosophers would have considered this a career capstone, the achievement that justified their life's work. Cavendish barely paused. There were other questions to investigate, other measurements to refine. The gravitational constant was known now. What else could be determined with sufficient care and proper equipment? But time was becoming a factor, not in the experiments themselves, which could continue indefinitely, but in the body performing them. Cavendish was aging, and the work was demanding. The body was aging. The mind remained sharp, but the physical apparatus that supported the experiments was wearing down. Cavendish was entering his 70s now, and the work required stamina. Long hours standing at equipment, extended periods of observation where you couldn't leave your post, the patience to repeat measurements dozens of times. But there was still work to do, always more work. The electrical experiments consumed him next. Electricity was mysterious then, poorly understood, full of spectacular demonstrations but short on systematic investigation. Benjamin Franklin had flown his kite. Luigi Galvani had made frog legs twitch. People knew electricity existed, could produce it, could store it in Leyden jars, but the fundamental principles remained unclear. Cavendish approached electricity the way he approached everything else, methodically, quantitatively, with instruments he built himself and procedures he refined obsessively. He constructed an artificial torpedo, a leather fish filled with materials that would simulate the electric shock produced by real torpedo fish. He used himself as a measuring instrument, deliberately shocking himself to compare the sensations. Different configurations, different intensities, careful notes about what each one felt like. This was before anyone understood that running electricity through your body might not be the safest experimental technique. But Cavendish needed data, and his own nervous system was the most readily available detector. He investigated electrical resistance, built circuits with wires of different materials, and measured how well they conducted. He didn't have precise instruments for this, so he improvised, used his body again as a detector. Different strengths of shock indicated different resistance. The method was crude but effective. He was mapping out principles that wouldn't be formally stated for another 50 years. The theoretical work went further. He developed a mathematical model of electrical attraction and repulsion, proposed that the force followed an inverse square law, similar to gravity. This was decades before Coulomb published the same conclusion and got his name attached to it. But Cavendish didn't publish. He just wrote it down in his notebooks and moved on to the next question. Why didn't he publish? We can only speculate. Maybe he didn't think the work was complete. Maybe he planned to eventually, but never got around to it. Maybe he simply didn't care about priority or recognition. The pattern was consistent throughout his life. Do the work, record the results, move on. Whether anyone else ever saw it seemed almost irrelevant to him. The notebooks filled up. Hundreds of pages of observations, calculations, diagrams, electrical circuits, chemical reactions, astronomical observations, temperature measurements. Anything that could be measured, he measured. Anything that could be calculated, he calculated. His contemporaries respected him, but found him baffling. Here was a man with extraordinary talent and unlimited resources who could have been famous, celebrated, influential. Instead, he worked in near isolation, published sparingly, avoided attention. The Royal Society valued his contributions but couldn't quite figure him out. The weekly dinners at the Royal Society Club remained his only regular social engagement. He showed up punctually, ate the same meal every time, spoke rarely. If someone approached him with a scientific question, he might respond. Anything else met silence. People learned to treat him like a particularly sensitive piece of equipment. Handle with care, follow the correct procedures, and you might get useful output. His wealth continued to grow. The inheritance from his father had been substantial. Investments multiplied it. By the early 1800s, he was one of the richest men in England. The Bank of England held enormous deposits in his name. He never spent it. The houses in London and Clapham Common served as laboratories. The finest instruments money could buy filled them, but personal luxury meant nothing. The clothing remained decades out of fashion, the same style his father had worn. When a suit wore out, he had his tailor make an exact replacement. The tailor knew better than to suggest updates or improvements. Just copy the old one. That's what Cavendish wanted. The servants communicated with him through notes left in designated locations. He left instructions. They left reports. The system worked efficiently without requiring conversation. The housekeeper he supposedly avoided by installing a back staircase likely appreciated the arrangement as much as he did. There was a story, possibly apocryphal, about a bank manager who tried to discuss Cavendish's enormous deposits, wanted to suggest investments, talk about interest, the usual financial management conversation. Cavendish was annoyed. The money was there, it was earning interest. What else was there to discuss? When the banker persisted, Cavendish threatened to withdraw everything and move it elsewhere unless the man stopped bothering him. The banker learned to leave him alone. Charity received systematic attention. Cavendish checked the subscription lists for scientific and educational causes, identified the largest donation, wrote a check for exactly that amount. This happened regularly, consistently, without emotion or fanfare. It was a system. It worked. Why would you need to do anything else? The scientific work continued. In 1801, at age 70, he was still conducting experiments. His interests ranged across all of natural philosophy, chemistry, physics, astronomy, geology. No boundary between disciplines existed in his mind. It was all measurement, all investigation, all part of understanding how the natural world operated. He studied heat, built instruments to measure thermal expansion in different materials, investigated how temperature affected chemical reactions, measured the heat produced when substances combined. This was decades before thermodynamics became a formal science, but Cavendish was already exploring its foundations. The astronomical observations continued. He maintained instruments at Clapham Common, recorded positions of stars and planets, calculated orbits. The work was meticulous but not groundbreaking. Astronomy had moved beyond what one person with a small observatory could contribute. But Cavendish didn't care about making revolutionary discoveries. He cared about accurate measurement. If his observations helped refine existing knowledge, that was enough. The younger generation of natural philosophers began to emerge. People who would later be called scientists, though that term didn't exist yet. They knew of Cavendish, respected his work, but found him increasingly remote. He belonged to an earlier era, the gentleman scientist, independently wealthy, pursuing knowledge for its own sake. The profession was changing. Institutions were forming. Universities were establishing research positions. Science was becoming organised, professionalised, collaborative. Cavendish remained apart from these changes. He worked alone. He published rarely. He attended Royal Society meetings, but participated minimally. The world was moving on, and he wasn't interested in moving with it. But the notebooks, those extraordinary notebooks, they contained discoveries that wouldn't be independently rediscovered for decades, insights into electricity, chemical reactions, heat transfer, all written down, calculated, verified through experiment, just sitting there in his study while the world remained ignorant of them. This raises an uncomfortable question. Does scientific discovery mean anything if nobody knows about it? Cavendish discovered Coulomb's law before Coulomb. He discovered Ohm's law before Ohm. He made contributions to thermodynamics before thermodynamics existed as a field. But because he didn't publish, he didn't get credit. Other people made the same discoveries later, published them, and got their names attached. Was Cavendish right to work this way? Should he have published more, claimed priority, established his place in history? Or was he actually right that the work itself mattered more than recognition? There's something almost pure about his approach, science stripped of ego, investigation for its own sake, no concern for fame or priority or establishing your name. Just the work, just the truth, just the measurements. But it's also wasteful. All that knowledge locked away, other researchers duplicating his efforts, progress delayed because information wasn't shared. Science is cumulative. It builds on what came before. If you don't share what you've discovered, you're not really contributing to that process, no matter how brilliant your work. Cavendish seemed untroubled by this contradiction. He was discovering truth, recording it. That was sufficient. Whether anyone else ever saw it was their problem, not his. The electrical research would remain hidden for 75 years after his death. Only when James Clerk Maxwell, working on his own electromagnetic theory, happened to examine Cavendish's papers did the full extent of the work become clear. Maxwell was astonished, published Cavendish's electrical researches in 1879. The scientific world learned that this eccentric 18th century aristocrat had anticipated huge portions of 19th century electrical theory. But Maxwell's publication came too late for Cavendish to receive contemporary credit. The discoveries belonged to history, not to him. Other names were already attached to the laws he'd found first. Did Cavendish care? Probably not. He was dead by then, obviously. But even if he'd been alive, it's hard to imagine him being bothered. He'd done the work. That was what mattered. The final years approached. Cavendish was in his late 70s now. The experiments continued, but at a reduced pace. The body couldn't maintain the previous schedule. Observation sessions grew shorter. The hand that wrote in the notebooks began to shake slightly. But the mind remained clear, the logic intact, the curiosity unsatisfied. There were still questions to investigate, measurements to make, calculations to perform. Age was an inconvenience, not a reason to stop. He'd lived an extraordinary life in the most ordinary possible way. No drama, no grand achievements celebrated in public, no students or followers, just decades of careful work, accumulating knowledge, one measurement at a time. The world around him had changed dramatically since his birth in 1731. Revolutions in America and France, the Industrial Revolution transforming England, political upheaval, social transformation. None of it seemed to affect him. He remained in his laboratories working on his experiments, indifferent to everything else. In 1809, he turned 78. The experiments continued, the notebooks filled. The Royal Society dinners happened weekly. The routine remained unchanged. What was he thinking in those final years? We can't know. He left no journal, no letters revealing inner thoughts. The notebooks contain only observations and calculations. If he reflected on his life, on what he'd accomplished or failed to accomplish, he didn't record it. Perhaps he didn't reflect at all. Perhaps he simply continued working, day after day, because that's what he'd always done. The work was the life was the work. There was no separation between them. The pattern he'd established in his 20s held until the end. Wake at the same time, work in the laboratory, record observations, attend meetings, return to work, sleep, repeat. For 60 years this was existence, not happiness or unhappiness, not fulfillment or emptiness, just work. On February 24, 1810, Henry Cavendish woke at his usual hour. He dressed in his usual clothes. He probably ate his usual breakfast, though we have no record of what that was. He was 78 years old, and he'd been feeling unwell for several days. But unwell didn't mean stop working. It never had. The servants noticed he seemed weaker than usual. His movements were slower. He struggled with tasks that had been automatic for decades, but he gave no indication that anything was wrong. No complaints. No requests for a doctor. Just the same silent routine he'd maintained for 60 years. Around midday, he told his servant he needed to rest. He went to his bedroom. Unusual, this. Cavendish didn't rest during the day. The servant became concerned, asked if he should fetch help. Cavendish refused. He wanted to be left alone. That was entirely normal. Being left alone was always what he wanted. The servant checked on him later that afternoon, found him unconscious. By evening, Henry Cavendish was dead. No dramatic final words, no deathbed revelations, no gathering of friends or family. He died the way he'd lived, alone, silent, offering no explanation. What killed him? We don't know precisely. Old age, certainly. His body had finally worn out after 78 years of use, but the specific cause wasn't recorded. Perhaps it was heart failure, perhaps a stroke, perhaps something else entirely. Medical records from 1810 weren't what they are now. The death itself was unremarkable. An old man dying peacefully in his home. Happened every day in London. Nothing unusual about it, except this particular old man had measured the density of the earth, had discovered the composition of water, had detected argon a century before anyone else would prove it existed, had conducted electrical experiments that wouldn't be published for another 70 years, had lived one of the strangest, most isolated, most productive scientific lives in history. And now he was gone. The funeral was held at All Saints' Church in Derby. A small affair, private. Cavendish would have approved of that, assuming he'd had opinions about his own funeral, which seems unlikely. He was buried in the family vault. The grave marker was simple, no lengthy epitaph, just his name and dates. Born 1731, died 1810. That was sufficient. The obituaries were respectful but brief. The scientific community acknowledged the loss of an important figure, mentioned his work on gases, his measurement of Earth's density, his contributions to the Royal Society, but there was no outpouring of grief, no sense that the world had lost an irreplaceable genius. Cavendish had been too isolated for that, too unknown outside the narrow circle of people who attended Royal Society meetings. Most of London didn't know he'd existed. Those who knew he'd existed didn't know what he'd accomplished. And what he'd accomplished was sitting in notebooks, in his house, unpublished, unshared, unknown. The estate was enormous. Cavendish died one of the richest men in England. The wealth went to relatives. The scientific instruments were sold or distributed. The houses were emptied. And the notebooks were inherited by his cousin, the Duke of Devonshire. They sat in the family archives for decades. Occasionally someone would look through them, notice the meticulous handwriting, the careful diagrams, the endless columns of numbers. But mostly they just sat there, accumulating dust, waiting. In 1871, more than 60 years after Cavendish's death, James Clerk Maxwell was appointed the first professor of experimental physics at Cambridge. He was already famous for his work on electromagnetism. The equations that unified electricity and magnetism bore his name. He was establishing a new laboratory at Cambridge, the Cavendish Laboratory, named in honour of the family that funded it. Maxwell became curious about the man whose name the laboratory bore, started asking questions, learned about the unpublished notebooks, asked to see them. The Duke of Devonshire agreed, sent the notebooks to Cambridge. Maxwell started reading, and then he couldn't stop. Page after page of electrical experiments, measurements of resistance and capacitance, investigations of conductivity, theoretical work on electric potential, all of it conducted between 1771 and 1781. All of it unpublished, and all of it anticipated discoveries that wouldn't be made officially until the 19th century. Ohm's law? Cavendish had found it 50 years before Georg Ohm. The relationship between current, voltage, and resistance. Measured it, recorded it, never told anyone. The inverse square law of electric force? Cavendish had tested it experimentally in 1772. Coulomb wouldn't publish his version until 1785. The concept of electric potential? Cavendish had developed a clear understanding of it, used it to analyse circuits, decades before it became part of standard electrical theory. Maxwell was stunned. He wrote to a colleague that Cavendish's electrical researches were a complete system of electrical knowledge, which might have placed him at the head of the science. But nobody had known. For a century, nobody had known. Maxwell decided to publish the notebooks, edited them, added commentary explaining their significance. The book appeared in 1879 titled The Electrical Researches of the Honourable Henry Cavendish. It ran to more than 400 pages, a complete systematic investigation of electricity conducted a century earlier and only now seeing light. The scientific world was amazed. Here was proof that this eccentric hermit had been decades ahead of his time, that he'd solved problems other scientists would struggle with for years, that his refusal to publish had deprived science of crucial insights that could have accelerated progress dramatically. But there was also frustration. Why hadn't he published? Why had he kept this to himself? The work was brilliant. The measurements were precise. The theoretical framework was sound. He could have been recognised as one of the great electrical researchers of his age. Instead, he'd let it all sit in notebooks, unused, unknown. Maxwell tried to understand Cavendish's motivations. Wrote in the introduction to the published researches that Cavendish cared more for investigation than for publication, that he probably did not consider it a part of his duty to lay his results before the world in a form fit for public consumption. That might be accurate, or it might be Maxwell trying to make sense of behaviour he couldn't fully comprehend. Why would someone do all that work and then hide it? The question has never been satisfactorily answered. We can speculate. Maybe Cavendish was perfectionist enough that nothing ever felt ready to publish. Maybe he was so indifferent to recognition that publication seemed pointless. Maybe he was socially anxious enough that the thought of public scrutiny was unbearable. Maybe he just didn't care whether anyone else ever saw his work. All of these are possible. None can be proven. Cavendish left no explanation. The notebooks contain observations and calculations, not motivations, not justifications, just facts. What we know for certain is that his refusal to publish cost him credit for discoveries that would have made him famous, cost science decades of progress in understanding electricity, cost the world knowledge that could have been useful. Was that wrong? From a modern perspective, absolutely. Scientists have an obligation to share their findings. That's how science works. You build on what others have discovered. If everyone kept their results private, progress would stop. But judging Cavendish by modern standards misses something important. He lived in a different time. The culture of science was different. The expectations were different. And his personality was so unusual that applying normal expectations to him doesn't make sense. He did the work, That's what mattered to him. The work was its own reward, everything else was irrelevant. Still, imagine if he'd published. Imagine if those electrical researches had appeared in the 1780s instead of 1879. How different would the history of science have been? Would other researchers have built on his work earlier? Would electrical theory have advanced faster? Would the Industrial Revolution have progressed differently, with better understanding of electricity decades sooner? We can't know. History doesn't offer alternative versions. We're stuck with what actually happened. And what happened was that Cavendish's electrical work remained hidden until long after his death. The same pattern repeated with other unpublished work. His chemical researches, his theoretical investigations, his meteorological observations, all of it sitting in notebooks, some published eventually, some still unpublished, a vast body of work that only specialists have ever examined. The Cavendish Laboratory at Cambridge became one of the world's great physics research institutions, produced dozens of Nobel Prize winners, made fundamental discoveries in atomic physics, molecular biology, radio astronomy. The irony is rich. The laboratory, named after a man who never collaborated, who worked alone, who refused to share his findings, became a centre of collaborative research and open publication. Would Cavendish have approved? Probably not, but he was dead by then. His opinion didn't matter anymore. What does matter is the question his life raises about scientific genius and scientific obligation. Is it enough to discover truth, or do you have an obligation to share it? Cavendish clearly believed the former. Modern science insists on the latter. Both positions have merit. Pure research done for its own sake, without concern for application or recognition, has a certain nobility. Knowledge pursued for knowledge's sake. Understanding sought for understanding's sake. That's what drove Cavendish. But science is also a collective enterprise. Each generation builds on what previous generations discovered. If you hoard your findings, you're not contributing to that collective project. You're not fulfilling your role in the larger scientific community. Cavendish existed in a strange middle ground. He participated in scientific institutions, attended meetings, served on committees, evaluated other people's work, but he didn't fully participate in the sharing of knowledge that makes science progress. He took from the collective pool of knowledge, but didn't consistently give back. Was that selfish, antisocial, or just the inevitable result of a personality so unusual it couldn't function normally in any social context, including scientific ones? The answer probably depends on how much you weight intentions versus outcomes. Cavendish didn't intend to harm science by not publishing. He wasn't trying to keep secrets or maintain advantages. He simply didn't see publication as necessary or important. The harm was unintentional, but the harm was real nonetheless. Science progresses through shared knowledge. Cavendish's refusal to share slowed that progress, not catastrophically. Other scientists made the same discoveries eventually, but progress was delayed. That delay had costs. The legacy he left is therefore complicated. Brilliant work, extraordinary precision, fundamental discoveries, but also isolation, secrecy, missed opportunities for collaboration and acceleration of scientific progress. He was undeniably a genius, possibly one of the greatest experimental scientists who ever lived, but also someone whose peculiarities prevented him from being as influential as he could have been. The notebooks that survived tell the story. Thousands of pages of careful observations, meticulous calculations, systematic investigations, all done alone, all kept private, all revealing a mind that understood nature with unusual clarity but couldn't or wouldn't communicate that understanding to others. That's the tragedy of Henry Cavendish. Not that he failed to discover things, he discovered plenty. Not that his work wasn't brilliant, it was. The tragedy is that so much of what he discovered remained locked away, hidden, unknown, useless to the broader scientific enterprise that could have benefited from it. He measured the world with extraordinary precision, but he couldn't quite connect with the world of other people. Couldn't bridge the gap between his isolated investigations and the collaborative nature of scientific progress. So he worked alone, discovered alone, died alone, and left behind a legacy that's simultaneously inspiring and frustrating. Inspiring because of what he accomplished, frustrating because of what he could have accomplished if he'd been willing or able to share. The question isn't whether Cavendish wasted his potential. The question is whether potential has meaning without impact. Think about what potential actually is. It's not a thing you possess. It's a thing other people see in you, a projection, an expectation. Cavendish had extraordinary potential by any measure. Brilliant mind, limitless resources, access to the best scientific community in the world. He could have been Newton. He could have been Lavoisier. He could have reshaped entire fields, but he chose not to. And that choice reveals something uncomfortable about how we think about genius and obligation. We assume that if you're capable of greatness, you're obligated to pursue it. That exceptional ability creates exceptional responsibility. But who says? Cavendish never asked to be brilliant. He didn't choose his mind any more than he chose his inheritance. The gifts were given to him by accident of birth. Why should receiving gifts you never requested create obligations you never accepted? This gets to the heart of what we expect from genius. We want it to serve us. We want brilliant people to make brilliant contributions that advance humanity. But what if the brilliant person just wants to be left alone? What if they're content measuring gases in their private laboratory without telling anyone the results? Are they obligated to share? Modern science says yes, emphatically. Publication is not optional, it's fundamental. Science advances through shared knowledge. If you discover something and don't publish, you haven't contributed to science. You've just satisfied your own curiosity. But Cavendish lived before that norm was absolute. In his era, gentlemen scientists often conducted private research. Publishing was one option among several. Some did it for recognition, others for priority. Some, like Cavendish, barely did it at all. He published enough to maintain his reputation, enough to be taken seriously, but whole areas of his research remained private. Not secret exactly. He'd discuss them with visitors, show them his apparatus, explain his methods, but he wouldn't write papers, wouldn't submit to journals, wouldn't make his work accessible to people who couldn't visit his laboratory. Was this antisocial? Absolutely. Was it harmful to science? Probably. But was it immoral? That's harder to answer. Consider what morality we're applying here. If we judge by modern standards, Cavendish failed his obligation to the scientific community. He had knowledge others needed, he withheld it. That's wrong by contemporary norms. But if we judge by his era's standards, he was within his rights. He was a private gentleman conducting private research. He shared what he chose to share. That was accepted practice. The problem is that we can't actually judge by his era's standards, because we're not in his era. We know what came after. We know that science became professionalized, collaborative, based on rapid publication and open exchange. We know that this system works better than the gentleman scientist model. So we judge Cavendish by hindsight, by the standards he couldn't have known would become universal. That seems unfair, but it's also unavoidable, because his choices had consequences that extended beyond his lifetime. Every discovery he made but didn't publish was a discovery other scientists had to make again. Every experiment he conducted but didn't describe was an experiment that had to be repeated. The duplication of effort was real. The delay in progress was real. Maxwell discovered this when he went through Cavendish's papers. Experiment after experiment that anticipated later discoveries. Results that matched what other scientists would find decades later, all sitting unused in notebooks. The waste was staggering. Not the waste of Cavendish's potential, that's abstract. the waste of actual scientific progress. Concrete, measurable, real. But here's the complication. Would forcing Cavendish to publish have actually helped? His personality made communication difficult. His writing was precise but dense. His experimental descriptions assumed the reader already understood advanced techniques. When he did publish, his papers were often too technical for most readers. Only the most skilled experimentalists could follow his methods. So even when he published, the impact was limited. His work on electricity went largely ignored during his lifetime, despite being published in Philosophical Transactions. People read it, they didn't understand it, they moved on. If he'd published everything, would that have changed? Maybe. Probably not. The issue wasn't just that he didn't publish. The issue was that his mind worked differently from other people's minds. The way he thought about problems, the way he designed experiments, the way he interpreted results, all of it was idiosyncratic. Making him publish more wouldn't have made him more comprehensible. It would just have created more papers that people struggled to understand. This suggests the real loss wasn't the unpublished work itself. The real loss was the absence of collaboration. If Cavendish had worked with others, if he'd explained his thinking to students or colleagues, if he'd engaged in the kind of intellectual exchange that makes science productive, his ideas would have spread. Publication is one way to share knowledge, but it's not the only way. Sometimes direct teaching matters more. Sometimes conversation matters more. Sometimes demonstration matters more. Cavendish did none of these. He worked alone, thought alone, discovered alone. That isolation was the real problem. Not the lack of publications, the lack of connection. And that takes us back to personality, because you can't separate Cavendish's scientific choices from his psychological makeup. His refusal to publish wasn't a philosophical position. It wasn't a principled stand against the emerging culture of scientific publication. It was the inevitable result of a mind that couldn't function normally in social contexts. He didn't choose isolation. He was isolated by his nature, the shyness, the awkwardness, the inability to engage in normal conversation. These weren't choices, they were conditions. So when we ask whether he wasted his potential, we're really asking whether someone with severe social difficulties should be judged by the standards of social engagement. Should someone who can barely speak to one person at a time be expected to communicate effectively with the entire scientific community? That seems unreasonable, but the consequences of his isolation remain real regardless of whether we think he should have overcome it. This creates an impossible situation. We can't blame him for being who he was, but we can regret that who he was prevented him from contributing as much as he might have. The tension is unresolvable. Both things are true simultaneously. He was a victim of his own psychology, and science was a victim of his limitations. What makes this particularly painful is that Cavendish himself seemed unaware of the problem. He didn't see his isolation as a limitation. He saw it as normal, as the proper way to conduct research. In his mind, science was about understanding nature. You designed experiments, you made observations, you drew conclusions. Publication was incidental, a formality, optional. This view isn't completely wrong. Science is about understanding nature. Publication is a formality, but the formality matters, because science is also about building on previous work, about letting others verify your results, about contributing to collective knowledge. Cavendish understood the first part. He didn't understand or care about the second part, and that disconnect explains why his legacy is so complicated. The work was brilliant. The impact was limited. Both facts are true. Both matter. Maxwell tried to correct this by publishing Cavendish's electrical researches. But by 1879, when Maxwell's edition appeared, the moment had passed. Other scientists had made the same discoveries Cavendish had made. They'd gotten the credit, the priority, the recognition. Publishing Cavendish's work a century late didn't change that. It just showed what might have been, what could have happened if Cavendish had shared his work when it was new, when it could have influenced other researchers, when it could have accelerated progress. The electrical work is the clearest example. Cavendish had worked out concepts that wouldn't be rediscovered until the 1820s and 1830s. Ohm's law, the concept of electrical potential, the relationship between current and resistance, all of it in his notebooks, all of it unpublished. If he'd published in the 1770s when he did this work, electrical science would have advanced decades earlier. Other researchers could have built on his foundations. The field would have progressed faster. Instead, they had to rediscover everything. Ohm did his work in the 1820s without knowing Cavendish had done similar work 50 years earlier. He got the credit because he published, because he shared. That's how science works. Publication determines priority. Priority determines credit. Credit determines legacy. Cavendish didn't care about any of this, which is admirable in some ways. He wasn't motivated by recognition or fame. He was motivated purely by curiosity, by the desire to understand. But that purity came with costs. For him, the cost was relative obscurity during his lifetime. For science, the cost was delayed progress. For other scientists, the cost was duplicated effort. Everyone paid something. Nobody benefited. That's the tragedy. And it's a tragedy that couldn't have been avoided without changing who Cavendish fundamentally was. You can't separate the isolation from the genius. They were intertwined. The same personality that made him an extraordinarily careful experimenter also made him incapable of normal scientific communication. One of the greatest experimental scientists who ever lived. Someone who made discoveries that anticipated future science by decades. Someone whose precision and methodology were unmatched. But also someone whose impact was limited by his inability or unwillingness to share. The notebook survived. That's something. Not enough, but something. They show us what he discovered. They let us appreciate his genius retrospectively. They prove he was as brilliant as his contemporaries suspected. But they don't change history. They don't accelerate the progress that happened without him. They're evidence of what might have been, not what was. That's the final assessment. Extraordinary talent, extraordinary achievement, limited impact, all true, all important, all part of understanding who Henry Cavendish was and what he contributed to science. He measured the world with unmatched precision, but he couldn't quite figure out how to share those measurements with the world of other people. That limitation defined his legacy as much as his brilliance did. The question becomes whether we should judge him by what he accomplished or what he could have accomplished, by what he shared or what he kept hidden. Modern science doesn't work like this anymore. We've built systems designed to prevent exactly what happened with Cavendish. Peer review, publication standards, open access, data repositories, all of it exists partly because we've learned what happens when knowledge stays locked away, when discoveries die with their discoverers. But those systems create their own problems: pressure to publish, rushed papers, competitive priority disputes. The incentive structure now pushes towards sharing too quickly rather than too slowly. You wonder what Cavendish would have thought of it. A world where scientists fight publicly over who discovered something first, where papers get retracted because the rush to publish overrode the need to be certain. He might have hated it even more than he hated the dinner parties. There's something almost admirable about his approach. He didn't care about credit, didn't care about recognition, cared only about understanding. That's pure in a way modern science rarely is. When your career depends on publications and citations and grant funding, it's hard to maintain that kind of detachment. Cavendish had the luxury of not needing any of it. The wealth meant he could pursue knowledge for its own sake without worrying about professional consequences. But luxury doesn't make it right. The knowledge he generated wasn't his to keep. That's the social contract of science, even if it wasn't as clearly articulated in the 18th century as it is now. You build on what others discovered. Others build on what you discover. Everyone contributes to a shared project of understanding the world. Cavendish contributed, just not as much as he could have, not as much as he should have. His death in 1810 closed the door permanently on any possibility of sharing what remained unpublished. He died at his house in Clapham Common on February 24th. He was 78 years old. The cause isn't recorded in detail, but contemporaries described a gradual decline over several months. He remained lucid until near the end, still interested in scientific questions, still making observations. He died alone. No family at his bedside, no close friends holding his hand, just servants he'd communicated with through written notes for decades. It's hard to imagine a lonelier end. But he'd chosen that loneliness, maintained it carefully throughout his entire adult life. The isolation at his death was just the final expression of how he'd always lived. The obituaries were respectful, but brief. He was remembered primarily for the Cavendish experiment, the weighing of the world. That single achievement was what most people knew him for. The hydrogen work got mentioned, the composition of water, but the electrical research remained unknown. The unpublished notebooks sat in the family's possession. His nephew inherited the bulk of his estate, the scientific instruments, the libraries, the notebooks. For decades, they remained essentially untouched. A few scientists knew about them, knew there was material there that had never been published, but accessing it required permission from the family, required someone willing to wade through decades of handwritten notes in Cavendish's difficult script. It took James Clerk Maxwell to make it happen. Maxwell, one of the greatest physicists of the 19th century, became interested in Cavendish's electrical work. In 1871, he took on the project of editing and publishing the notebooks. It took 8 years. The result was a massive volume, published in 1879, titled The Electrical Researches of the Honourable Henry Cavendish. It revealed everything: the complete scope of Cavendish's electrical experiments, the concepts he'd worked out, the measurements he'd made, the theories he'd developed. Reading Maxwell's edition now is a strange experience. You see the brilliance clearly. Cavendish had figured out relationships between electrical quantities that other scientists would struggle with for decades. He'd measured conductivity with remarkable precision. He'd worked out the inverse square law for electrical force. He'd essentially discovered what we now call Ohm's law, which wouldn't be formally published until 1827, nearly 50 years after Cavendish's work. But you also see the limitations of posthumous publication. By 1879, when Maxwell's edition appeared, electrical science had moved far beyond where Cavendish had left it. The discoveries in his notebooks were historically interesting, but no longer scientifically useful. The moment when they could have influenced ongoing research had passed decades earlier. What might have been transformative in 1780 was merely confirmatory in 1879. Maxwell himself understood this. His introduction acknowledges that Cavendish's work was brilliant, but also that its delayed publication meant it couldn't claim priority, couldn't change how credit was assigned for electrical discoveries. The scientists who rediscovered Cavendish's results and published them first got to keep their names attached to the laws and principles. Cavendish's work proved he'd been there first, but proving it a century later didn't change anything. This is what makes the story frustrating. Not just that Cavendish didn't publish, but that his choice to not publish meant other scientists had to do the same work over again, had to make the same observations, work through the same problems, arrive at the same conclusions, all of it redundant, all of it unnecessary if Cavendish had just shared. Science is cumulative. That's its fundamental nature. Each generation builds on what the previous generation discovered. When someone keeps their discoveries private, they break that chain. They force the next generation to start over. The knowledge eventually gets rediscovered, but the time lost can't be recovered. That time could have been spent pushing further, understanding more, discovering things beyond what Cavendish had figured out. How many years of progress did science lose because Cavendish kept his electrical work private? Impossible to calculate exactly, but certainly decades. If his work had been published in the 1770s and 1780s when he did it, electrical science in the early 19th century would have been far more advanced. The researchers working on electricity in the 1820s and 1830s could have started from a much more sophisticated foundation. They could have reached the discoveries of the 1850s and 1860s, 20 or 30 years earlier. That's the cost, not just to Cavendish's reputation, but to human knowledge, to everyone who could have benefited from faster scientific progress. You can't measure that cost precisely, but you know it exists, you know it matters. Yet there's something that needs acknowledging. Cavendish couldn't have been different. The personality that made him such a careful experimenter was inseparable from the personality that made him unable to publish freely. You can't extract the positive qualities and discard the problematic ones. They were all part of the same person, the same psychology, the same way of being in the world. Expecting Cavendish to be more social, more communicative, more willing to share, is like expecting someone to change their fundamental nature. It wasn't possible, not with the understanding of psychology available in the 18th century, maybe not even with modern treatment. His isolation was profound. His social difficulties were severe. They weren't choices in the way we usually think of choices. They were closer to fundamental aspects of his personality that he couldn't have changed, even if he'd wanted to. Which raises an uncomfortable question. Would we rather have had Cavendish exactly as he was, with all his achievements and all his limitations? Or would we prefer he'd been different enough to publish freely, even if that difference meant he wouldn't have been quite as brilliant an experimenter? There's no good answer. Both outcomes have value. Both have costs. We got one version of history. We can imagine the other, but never know how it would have actually played out. What we know for certain is that Henry Cavendish represents an extreme case of a broader tension in science. The tension between individual genius and collective progress, between personal satisfaction and social responsibility, between the freedom to work in private and the obligation to share. Every scientist navigates these tensions differently. Most find some balance between private research and public communication. Cavendish found no balance at all. He chose one extreme completely. That choice gave us some remarkable discoveries: the density of Earth, the composition of water, the properties of hydrogen. These achievements came directly from his methodical, isolated approach. They required the kind of sustained, careful attention that Cavendish could maintain, precisely because he wasn't distracted by normal social obligations. The weighing of the world wouldn't have happened without someone willing to watch a torsion balance oscillate for hours at a time, without someone obsessive enough to account for every possible source of error, without someone who had nothing else to do but science. But that same choice cost us other discoveries, or at least cost us the timely dissemination of them. The electrical work, the unpublished chemistry, the observations that never became papers, all of it lost or delayed because Cavendish couldn't or wouldn't share. The isolation that enabled some achievements prevented others from having the impact they should have had. So we're left with Henry Cavendish as a permanent reminder of what brilliance looks like when it can't quite connect with the world around it. A man who could measure the Earth's density to within 1% but couldn't manage a normal conversation. Who could detect gases in concentrations below 1% but couldn't tolerate being in a room with women. Who revolutionized chemistry but did it so quietly that most people didn't notice. He died wealthy, respected within narrow scientific circles, and utterly alone. The wealth meant nothing to him. The respect was probably uncomfortable. The isolation was what he'd carefully maintained for 8 decades. In that sense, his life was exactly what he'd chosen. what he'd worked to create and preserve. Nobody can say he didn't get what he wanted. Whether what he wanted was what he needed is another question entirely. One we can't answer because we can't ask him. All we have are the facts, the experiments, the notebooks, the legacy of brilliant work that influenced science less than it could have. That's who Henry Cavendish was. That's what he left behind. Extraordinary achievement shadowed by extraordinary limitation. Both real, both significant. Both permanent parts of how we understand what happened when one of history's most brilliant minds encountered one of history's most isolated personalities. The measurements were precise, the life was not. The notebooks eventually found their way to Cambridge. The Cavendish Laboratory was named after the family in 1874, funded by the 7th Duke of Devonshire. Maxwell became its first director and discovered the electrical papers. That's how we know what Cavendish actually did in those decades of isolation. Without Maxwell's curiosity, the electrical work might have stayed buried forever. Just another pile of old papers in an aristocratic family's archives. But even Maxwell's publication couldn't fix the fundamental problem. Cavendish's discoveries entered the historical record too late to matter scientifically. They became footnotes, interesting historical details about who got there first. But priority without publication is just private satisfaction. It doesn't change anything. This is the paradox at the centre of Cavendish's life. He was undeniably brilliant, possibly one of the greatest experimental scientists who ever lived. The precision of his work remains impressive, even by modern standards. His methodology was decades ahead of his time. When he measured something, he measured it right. But brilliance without communication is incomplete. Science isn't just about discovering truth, it's about sharing truth so others can build on it. Cavendish understood the first part perfectly. He never understood the second part at all. Or maybe he understood it and simply didn't care. We'll never know which because he left no explanation. What we're left with is a cautionary tale about genius and isolation, about what happens when extraordinary ability encounters extraordinary dysfunction. The two didn't cancel out, they coexisted, produced remarkable achievements alongside remarkable limitations. Modern science has tried to prevent this pattern from repeating. Publication is mandatory now. Data must be shared. Methods must be described in detail. Reproducibility is fundamental. The entire structure is built around making sure knowledge doesn't die with the person who discovered it. But those systems come with their own costs. Pressure to publish encourages rushed work. Priority disputes create conflict. The incentive structure rewards quantity sometimes over quality. You wonder what Cavendish would have thought of modern academia? Probably nothing good. Still, the modern approach works better. Science progresses faster when knowledge is shared immediately, when experiments can be replicated and extended by others, when discovery builds on discovery in real time rather than decades later. Cavendish represents the old way, the gentleman scientist pursuing knowledge for its own sake. No pressure to publish, no career consequences for keeping work private, no obligation to anyone except himself. That way is gone now, probably for the best, but something was lost too. The purity of investigation divorced from professional advancement, the freedom to work without worrying about credit or recognition, the ability to spend years perfecting experiments without anyone demanding results. Cavendish had that freedom, used it to produce work of extraordinary quality, but also used it to keep that work private longer than science could afford. His legacy is therefore split. The weighing of the world stands as one of the great experimental achievements in physics. That work was published, became famous, influenced how scientists thought about gravity and the Earth's composition. It deserves its place in history. The electrical work is different, brilliant but buried, discovered too late to matter scientifically. It proves Cavendish was ahead of his time, but doesn't change the fact that being ahead of your time means nothing if nobody knows about it. Between these two extremes lies everything else Cavendish did. The chemistry, the atmospheric measurements, the heat studies, some published, some not. All meticulously recorded in notebooks that mostly gathered dust for decades. What should we make of him? Not a hero, certainly. Heroes share their discoveries, contribute to collective progress. Cavendish did some of that, but not enough. Not a villain either. He wasn't deliberately withholding knowledge to maintain advantage. He wasn't competing unfairly. He simply didn't see publication as important. That was wrong, but it wasn't malicious. Maybe the right word is tragic. Tragic that such extraordinary ability was paired with such profound social dysfunction. Tragic that someone capable of understanding nature with unusual clarity couldn't figure out how to communicate with other people. Tragic that the isolation that enabled some achievements prevented others from having the impact they deserved. He spent 78 years measuring the world with unprecedented precision. He understood matter and energy in ways his contemporaries couldn't match. He developed experimental techniques that wouldn't be equaled for generations. All of this happened in near total isolation, protected by wealth, enabled by privilege, limited by personality. The man who weighed the earth couldn't weigh himself against normal human expectations, couldn't balance the desire for private investigation against the obligation to share, couldn't bridge the gap between his laboratory and the larger scientific community. So he remains this strange figure in the history of science, undeniably important but also somehow marginal, brilliant but limited, revolutionary but isolated. His name is attached to a laboratory he never saw. His electrical work is credited to others who published first. His greatest achievement, measuring Earth's density, is remembered more for the experiment than the experimenter. That's probably how he would have wanted it. The work mattering more than the person, the measurements outlasting the measurer, the truth standing independent of who discovered it. But it's not how science actually works. Science is human, built by people, shaped by personalities, influenced by who shares and who doesn't. The knowledge Cavendish generated didn't exist in some pure realm separate from his choices about publication. Those choices shaped what that knowledge could do, what impact it could have, who it could help. He made the wrong choices, not deliberately, not maliciously, just inevitably given who he was. And science paid the price through delayed progress, through duplicated effort, through knowledge that sat unused while the world needed it. That's the final verdict. Extraordinary scientist, extraordinary achievements, extraordinary waste of potential impact. All three things true simultaneously. All three things important for understanding what happened when one of history's most brilliant minds spent 8 decades working alone. The measurements were precise, the methodology was sound, the discoveries were real, but the isolation was complete. And completeness in isolation, no matter how brilliant, will always be less than what collaboration could have achieved. Henry Cavendish weighed the world, but he never quite figured out how to be part of it